guys, welcome to this video. We're going to have a look at a few worked examples of this idea of loci in the complex plane. So I'm just taking an example here. This one's actually in your workbook, but I just want to work through this in a bit more detail with you. Okay, so here's a pretty typical question. In fact, there was something similar to this in the 2014 NCA paper. But basically what we want to do is find a locus of points that represents the situation where the modulus of this complex number is equal to the modulus of this complex number. Okay, so what would that look like? Well, let's just work our way through it and see. So here's a typical kind of method that you use in situations like this. Okay, what we're going to do is let z be a general complex number. Then we're going to substitute into the left and right hand sides. Get the modulus, because it's asking us to here, of both of these and see what plays out when we get the modulus, what falls out of that. Okay, so the two real parts are x minus 1, and we've got an imaginary part there, y. So I'll just group these together so you can see the real and imaginary parts more clearly. Now, to get the modulus, you might recall that it's essentially applying Pythagoras' theorem. It's the distance from the origin. Okay, so what we've got is the real part squared plus the imaginary part squared, the square root of that. So we're going to get the square root of x minus 1 squared plus y squared, and very similar on the other side. Now, since we have a situation here, we've got the square root equal to the square root of something. Okay, just square root equaling square root. If that was the situation here, then it's quite legitimate to square both sides, giving us the situation here that whatever those two variables are, that they would be equal to one another. So applying the same idea here, we're going to square both sides, and at the same time I'm going to expand these brackets here. So squaring both sides and squaring the two brackets, I'm going to end up with x squared minus 2x plus 1 plus y squared equal to, on the other side, x squared minus 6x plus 9 plus y squared. Let's just check that again. Yes, that looks right. Now, what we do have are the same variables on both sides here, and they can be cancelled. Okay, and let's bring together onto one side the x variables. Let's move the x variables to the right, no, in fact to the left, so they end up being positive. So we get negative 2x plus 6x, and let's move the numbers to the other side. This is going to give 4x is equal to 8, which simplifies down to x equals 2. So what this is saying is that the line x equals 2 represents the situation where the modulus of this complex number, okay, or the modulus of all the complex numbers, where the modulus of it would be z, the modulus of z minus 1 would equal the modulus of z minus 3. So we would have a situation something like this. If I can just draw a line, try and get it to be straight, and another line this way. Okay, and let's go back to the pencil tool for a moment. So if that was 2 there, okay, and let's get our line back again, but let's change the color to something like green. We would have a situation, so I can line this up. Okay, pretty good. Okay, so that line there, it represents all the points where this modulus is equal to this modulus. And yes, there is a reason why it's halfway between 1 and 3, because if you look at this complex number, it represents all the complex numbers where you've essentially moved everything to the right by 1. And this represents all the complex numbers that have been moved to the right by 3. And so halfway between those, the distance basically for each of them, where the distance between them, okay, are equal, would be the line down the middle there. Okay, so that's one worked example. Now I'm going to put a question or two in the video now, just to see if you can do something similar to this yourself. And then in a second video I will have a look at another worked example where we end up with something which is not a straight line, perhaps either a circle or an ellipse. Okay, we'll catch you in class then. So here comes the first question. And here comes the second question.